time ago, when we were talking about the coherent transceivers, it was said that using them will simplify the network design. Does it really look like this?
Using the coherent transceiver itself, maybe not, but the new optics, the QSFP-DD, DWDM coherent optics, which allow us to take this path, to go this path, because QSFP-DD could be installed directly into the network equipment. So when the coherent transceiver, with all the idea of the OTN transport, will be installed directly in the network device, we could basically we will not need transponders. If we don't need transponder, it means that we could also skip the gray optics to build the connections between the network devices and transport devices. This make our network much more simple. And what else we benefit with such a network concept, with such network idea? We also reduce the space in the rack we need. We reduce the power consumption, and this is the huge benefits of the installing the DWDM transceiver directly into the network equipment. Also, by reducing the number of active equipment, we are able to lower the value of the delay between points because we have less system regeneration.
It is possible thanks to the new standards, because in older generation of coherent optics, we have not so simple situation. There was a lot of incompatibility between vendors, and QSFP-DD standard and CMIS related to this kind of transceivers made the situation much easier and clear, and we can really talk about standardization and unification of such solutions. And thanks to this standardization, we can really connect or establish coherent transmission between transceivers and equipment from the offer of different vendors. Generally, we have two standards for coherent QSFP-DD optics. One is developed by OIF organization, and it is OIF 400ZR standard, which is mainly dedicated for transmission inside and between data centers. Those transceivers support Ethernet transmission on the distance up to 120 kilometers. Use one error correction algorithm CFEC, and use one type of modulation 16 QAM. And the second standard is MSA OpenZR Plus. It is standard for coherent transceiver supporting not only Ethernet transmission but also OTN for transmission. And within this standard, transceivers could support much more modes of work. I mean, different transmission speed, different error correction algorithms, and different kind of modulation. Thanks to that, we can reach the very good transmission standards even on the transmission lines with very low OSNR.
So how about in terms of distance? What are the maximum distances we can reach?
The maximum distance, of course, will depend on the network quality. And one of the factors we could measure the network quality is optical to signal noise ratio. And for 400G ZR, standardized by OIF, the one who is responsible for the data center interconnection, here we are talking about 24 dB. But if we go to the MSA standard, which also introduce more operation mode, so from the host point of view, such kind of transceiver could support 400 gigabit Ethernet, could support few 100 gigabit Ethernet transmission or few OTU4. So with depends how much data we will carry on the line side, we could reach the different distance, because modulation in the MSA standard transceiver could be changed from QPSK up to 16 QAM. So with 16 QAM and the OFEC correction methods, we are able to reach up to 22 dB in terms of the SNR parameter. But if you go to QPSK and 100 gigabit line speed, we are able to get the working path even with SNR on the level around 10 dB. So talking about the distance, 10 dB, it could be even few thousand kilometers. 22 dB, it's around 500, 600 kilometers. So the distance we are able to reach now using the 200G coherent optics from the previous generation. So it's pretty impressive.
So actually, we can reach really long distances. We can build the actual long haul connections without transponders, with the transceivers installed directly in routers or switches, right?
Exactly.